Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are looking at some advanced ionic bonding. Don't be thrown off by the name. Yes, there is a new trick. However, it does follow all the other rules of ionic bonding that we have been practicing. So the new trick, or what was being introduced, is a polyatomic ion. So polyatomic means many atoms. So therefore, a polyatomic ion is an ion that is made out of more than one atom. So you should write that down on your definition sheet right now. So next we have some examples of polyatomic ions. The example given is sulfate. So one of the things I want to point out is that sulfate is made up of one sulfur, four oxygens with a -2 charge. Yes, it is made up of sulfur and oxygen. However, when it is in this form, it's no longer sulfur and oxygen. It's sulfate. It's its own entity. It's not sulfur and oxygen. It's sulfate. That will be extremely important to understand when we are moving on in some of the later problems when we are using the crisscross method with polyatomic ions. So next there are some more examples. So these are many of the polyatomic ions that end in 8. These are other polyatomic ions that don't really have too much of a name change, or a name change that's significant. So when it ends in 8, I've highlighted part of the formula that is important. It's what the 8 symbolizes. This will help you with question 1. These two lists, accelerated students will have to memorize. CP students will be given these. You'll just have to know how to use it. So question 1, what do all of the polyatomic ions that have 8 have in common? Check what I highlighted for you guys. So then next, question 2, so what do you think that the polyatomic ion silicate is made out of? So break it up into its roots. You have silly and 8. What element do you think silly is like, and what does 8 represent? So question 3, you are thinking about the difference between I'd and 8. So I'd goes back to the last Chemquest. 8, again, what we just talked about, what does 8 symbolize? This difference is extremely important. You'll be using this difference later in the Chemquest when we are crisscrossing, when we are writing formulas with polyatomic ions. You will have to be able to identify or be able to know the difference when it's just a regular ion and when it is a polyatomic ion. This is the difference. It's a regular ion when it ends in "ide." It's a polyatomic ion when it ends in "ate." So next, we have some information. We have some writing formulas with polyatomic ions. So this goes back to crisscrossing. So again, we're going to do our crisscross method. So step 1 is to write the ion with the charge. So we have +1 from sodium, -2 from sulfate. Next, we crisscross. We cross off the charges, and then we bring the numbers down. So if we bring the numbers over, it tells us we need 2 sodiums and 1 sulfate. Lots of times, people put polyatomic ions in parentheses. This is an example where you don't need to have them. There are specific examples, which you'll see in the next example, when you need to have parentheses. I always put parentheses around my polyatomic ions. That way I don't have to remember when to use parentheses and when not to parentheses. They're always there, whether you need it or not. So then next is the example of magnesium nitrate. This is an example where you will need parentheses. So remember, we had said that all polyatomic ions are their own entity. We can't break them up. So what I would do is I would put parentheses in right here, and I would put parentheses in right there as well. So then we put our polyatomic ion in parentheses. We add our charges. We then block off the sign of the charge, and we bring our numbers down. If we bring our numbers down and we don't have parentheses, what this is telling us is you have 1 magnesium, 1 nitrogen, and 32 oxygens. When you have parentheses, it's just like math. You have to distribute the 2. So when you have parentheses, this 2 goes there, and this 2 goes here. It's multiplied by everything that's in the parentheses. So then the arrows symbolize times 2. So then you're going to multiply times 1 right here to have 2 nitrogens and then you're going to multiply 2 times 3 to have 6 oxygens, and we still have 1 magnesium. So you can see the difference between when we need parentheses and when we don't have parentheses. We need parentheses when there is going to be a number greater than 1 next to the polyatomic ion. Typically, all the polyatomic ions, they end with a subscript that is greater than 1. So if you don't have parentheses, it would look like this. It would look like 32 oxygens versus 2 nitrogens and 6 oxygens. As you can tell, it's a very different formula. So again, make sure you put polyatomic ions in parentheses. Next, there's just a few more examples of polyatomic ions. You can practice crisscrossing with the charges to make sure that you get these answers. I guess I can do one for you. So if we're doing the first example, we would look at potassium. Potassium has a +1 charge. And then next is acetate. So again, I always write my polyatomic ions in parentheses, whether I need them or not. Just in case I do need them, then they're always there. Acetate has a -1 charge, so we can cross off our charges, and then we can crisscross. So this would give us K1, and then it would give us C2H3O2 1. And then you write down exactly what you see here. You don't have to write the ones because they are the same. We can do this example right here. Magnesium nitrate. Magnesium has a +2 charge. Nitrate has a -1 charge. Again, we put our polyatomic ion in parentheses, and then we crisscross. 1, 2. Mg1, NO3, 2. As you can see, the 2 is on the outside of the parentheses. That's because this 2 goes to this 3 to have 6 oxygens, and then this 2 goes to this nitrogen to have 2 nitrogens. So again, remember, when you clear parentheses, you have to multiply the number that's on the outside of the parentheses by all of the subscripts that are on the inside. This will be helpful when you are working on the next couple questions. In the next couple questions, you have to do just that. So when you're working on question 4, remember this 2 right here goes to this, goes to that nitrogen, and also to this carbon. It does not go to the magnesium, and it does not go to the magnesium because the magnesium is on the outside of the parentheses. So next, you can do the same thing for 5, figure out how many of each atom you have. The rest of the questions are just using what you know about ionic bonding to answer the questions. You have both included. You have examples with regular ions that end in "ide," and you have examples with polyatomic ions that end in "ate." So remember the difference while you're working. You do have to remember the 2 rules. You have to remember the 2 rules for ionic bonding. You will have to remember that the positive ion always comes first in a chemical formula, in an ionic formula. And then you also have to remember that all ionic compounds want to have a neutral charge. So that's how we determine how many of each we have, is trying to make the charge neutral. So again, that is everything you need to know to answer the rest of the questions. Oh, I lied. I'm sorry. There's some information on acids that I forgot about. So we do have some information on acids. So acids are compounds that contain a positive hydrogen, H+ bonded to any negative ion. So this is your definition for an acid. You can put that onto your definition sheet. The example is carbonic acid. It's formed by the carbonate ion. So carbonate ion has a -2 charge. We know that hydrogens have a +1 charge. So to make this neutral, you would need to have 2 hydrogens. So that's what we see in this formula. We have H2CO3. You need 2 hydrogens to balance out the 1 carbonate ion. Again, this list right here, accelerated students will have to memorize it. CP students will be given it. So then think about question 11. So why do carbonic and sulfuric acid require 2 hydrogens, but HCl and HNO3 only require 1? So you have to remember carbonic acid has a -2 charge. Sulfuric acid, so sulfate has a -2 charge. You have to remember chlorine. Chlorine has a -1 charge, and NO3 has a -1 charge. Remember, hydrogen has a +1 charge. And then you have to try to remember, what do all ionic compounds want to have their overall charge be? And then that's how we determine how many hydrogens we have. Question 12. So question 12, I'm not going to give you any hints on. So look up the charge for phosphoric acid, or sorry, for the phosphate ion, and then figure out how many ions you need. Remember, if you have any questions, please circle it, write down your question. That way you won't have to remember it from when you're working at home till when you come to class. Make sure you ask me any questions you have, and we'll take it from there. Hope everyone has a good one.